Good morning, class, at 7:30 a.m. Now let's prove that the empty set star is equal to the set that contains the empty string. Good morning, class, at 7:30 a.m. We are going to now prove that the empty set... Good morning, class. Good morning, class, at 7:30 a.m. Now we're going to prove that the empty set star is equal to the set that contains the empty string. Okay, so let's say that we have a language L, and now we're going to look at the language LL, which is the concatenation of L, and that is defined to be this. Okay, so we're going to look at the consider a language L that can be any language. Now we're going to consider the language LL, which is just the concatenation of L with itself. And that is the set of all strings Wx, where W and X are from L. And one thing that we'll prove is that if L is regular, then LL is also regular. Okay, so in contrast, now we're going to look at the language WW, where W is in L. So know this language is not the same as concatenation, because here is the same string twice. No, this language is not the same as this language. In fact, I just said that if L is regular, then this guy is regular, but this one is not even regular at all. Okay, so we're going to now formally show what the NFA to DFA conversion actually does. So it's this. Is that right? No, that's not right. For those of you watching the outtakes, you'll see this. So it's this. No, that's right. Yeah, so I have to do epsilon closure in here too. From each individual state, yeah. So delta x a. Yep, that's right. So it's actually very, very simple. So all you have to do is to find out. So it's actually very simple. All you have to do is to look at a subset of states of the NFA on a particular symbol A. So this is what it's defined to do in the DFA. And then all you have to do is to figure out where it went in the NFA, figure out the epsilon closure of that, then take the union of all individual states in that particular set of states, and then take the epsilon closure of that. It's just completely obvious. So we're going to be looking at the NFA to regex conversion process today. Anyway, what do I have to say after? Anyway, we need to have an intermediate object because we can't necessarily do this directly. So that intermediate object is called a generalized NFA, and that's more commonly abbreviated as a GNFA. One thing to keep in mind is how to know the difference between a pushdown automaton transition and a Turing machine transition, because it's easy to get those mixed up. Sure, the PDA one, if we have a transition that looks like this, is going to be looking like A, comma, B goes to C, where A is the thing that's being read, B is the thing that's being popped off the stack, and C is being the thing that's being pushed. So that's the PDA. So that's the PDA. And then the Turing machine version of this, the transition, is going to be A goes to B, comma, C, where A is the thing being read, B is the thing being written, and C is the direction. So what you should notice is that there's an arrow over here between the B and the C, and for the Turing machine, it's between the A and the B. Don't get these mixed up. No. Because clearly everyone else does it, and therefore that's the reason why we should do it. Okay, class, now we're going to prove one of the most important things in the entire class, which is that the halting problem is undecidable. There's no algorithm to figure out whether a Turing machine halts on a given input. Basically, we will assume that this thing is decidable and then get a contradiction as a result. Essentially, we will get a Turing machine off of this assumption that disagrees with itself. So on a particular input, it's supposed to have certain behavior, and it really is doing the other behavior, so it's disagreeing with itself. By feeding the Turing machine into itself. Okay, class, now we're going to use... Okay, class, today we're going to be proving a much easier way Okay, class, now we're going to look at a much easier way to show that something is undecidable. All right. It's basically called Rice's theorem. Okay. That's all I need to do there. Because Turing machine recognizers can run forever, we need to introduce this idea where if we want to combine two recognizers, we don't want them to run forever in total, so we introduce this idea of dovetailing. That's all I need to do there. Okay, class, we're going to be looking at a really cool proof of undecidability called the Postcorrespondence Problem, and for short. Okay, class, today we're going to be looking at a really cool application of undecidability called the Postcorrespondence Problem, or PCP for short. It turns out that a lot of proofs of undecidability, other than this one, can be used. It turns out that a lot of proofs of undecidability can be done with PCP. I must have landed on Mars. Am I on Mars? Let's see. Wait, did I just land on Mars? I think I'm on Mars. Got it, so we can make an NFA that epsilon transitions into the second copy. Got it, so we can make an NFA that epsilon transitions into the second copy. Got it. So we can make an NFA for that language L because we know it's regular, and epsilon transition into a second copy of that NFA. Wait, isn't that the same? Wait, aren't those two the same? Wait, aren't those two the same? Wait, aren't those two the same? Okay, well, how will that be done? Okay, how will that be done? Okay, how will that be done, though? Okay, how will that be done, though? Okay, how will that be done, though? I've always wanted to do that as a kid. Maybe I should make this a little closer. I've always wanted to do that as a kid. I've always wanted to do that as a kid. I've always wanted to do that as a kid. How does that work? How does that work? How does that work? Will these acronyms keep getting longer? How many three-letter acronyms? How many acronyms do we need to memorize? How many acronyms do we need to memorize? Can you remind us what the difference is? Should I get an actual utensil for this? Can you remind us what the difference is? Can you remind us what the difference is? That seems unnecessarily close. Can you make those a little different? That seems pretty close. Can you make those a little different? Wait, why not? Wait, why not? Wait, why not? Why not? You're the teacher. I'm a head out. I'm a head out. I'm a head out. I'm a head out. Do one more. I'm a head out. Okay. Hopefully this is good. How does that work? Got it, got it, got it. All right, that's fine. How the hell is that possible? How the hell is that possible? What? What? Oh, thank God. Oh, thank freaking goodness, finally. Anyone hankering for basmati? I have a hankering for basmati. Anyone have a hankering for basmati? Anyone have a hankering for basmati? So apparently I'm in a class called Intro Theoretical Woodworking. Probably keep my vision straight. So apparently I'm in a class called Intro Theoretical Woodworking. I did it again. So apparently I'm in a class called Intro Theoretical Woodworking. That's probably good, I'll do one more. So apparently I'm in a class called Intro Theoretical Woodworking. We're learning about drugs. We're learning about drugs. Are we seriously learning about drugs? Are we seriously learning about drugs? The problem or the 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 drugs?